Alright, one more video out of the 3. If you have not watched Simplifying Square Roots, my first video, and if you have not watched Adding and Subtracting Square Roots, it may or may not help you with this stuff, the thing about rationalizing the denominator, but it certainly helps to have an understanding of square roots, and that's a pretty good way to start. That stuff that I talk about in the other 2 videos. Here's the idea with rationalizing the denominator. The word rational means that it can be written as a fraction. And square roots, if they're not a nice, neat square root, like the square root of 7 can't be written as a fraction because it's an unending string of non-repeating decimals. It just never ends. Things like pi work the same way. They're irrational. The denominator is the bottom of the fraction. So what we're just saying here, this is a fancy way, rationalizing the denominator is a fancy way of saying, take that square root that's in the bottom of the fraction. Take it, and if you're going to have a square root, if you have to have a square root in your answer, put it in the top, put it in the numerator. That's all this is doing. So here's the trick, is anytime I have a square root on the bottom of a fraction, all I'm going to do is I'm going to multiply both the top and the bottom of the fraction by that number, the square root of 7. And when I multiply 2 fractions together, I take the top times the top, I just go straight across. It's not cross multiplication. Okay, that's kind of confusing for some kids. Cross multiplication only happens with an equal sign in between. But if I take 1 times the square root of 7, I have 1 square root of 7. And on the bottom, if I take the square root of 7 times the square root of 7, I get the square root of 49. But we know the square root of 49. Put that in your calculator, you'll find out that it's 7. Basically what happens is the square root sign just disappears. And it turns out that the 1 over the square root of 7, if you put that on your calculator, 1 divided by the square root of 7, that would give you the same thing as entering the square root of 7 divided by 7. They're the exact same value decimal-wise. So if I look at a problem like this, 1 over the square root of 10, all that means is that I'm going to take both the top and the bottom of the fraction, I'm going to multiply them by the square root of 10. Now you want to make this one more difficult? Here, make that a 2. Okay? So if I have 2 times the square root of 10, I have 2 times the square root of 10. And on the bottom, the square root of 10 times the square root of 10 is the square root of 100. But you know the square root of 100. That's 10. In other words, the square root sign just goes away. Now the only thing that's different about this problem is that once you get numbers, and this is important, once you get numbers outside of the square root sign, only the numbers outside the square root, in this case the 2 and the 10, now I can simplify it like a regular fraction. 2 over 10 reduces to 1 over 5. So I would reduce that to 1 over 5. And so I'd end up with something like this. The square root of 10 over 5. That's my rationalized denominator. Okay, 2 more examples, and then we'll be done. On this one here, once again, multiply by the square root of 7 over the square root of 7. I end up with 14 square roots of 7 on the top. The square root disappears on the bottom. And now I look at the numbers outside the square root and see, do they simplify? 14 over 7 becomes 2 over 1. That's 2 square roots of 7. Last problem. Multiply both top and bottom by the square root of 10. 20 times the square root of 10 on top. The square root sign goes away on the bottom. I look at the numbers outside the square root, they do reduce. 20 over 10 becomes 2 over 1. So my final answer is 2 square roots of 10. And that's how you rationalize the denominator.